Okay, stats. We are on 2-3. If you guys want to go ahead and turn in your maps data project, if you have that done, you can set it on the corner of my desk and turn that in. But we're going to do 2-3 today. It's graphs that the title is graphs that enlighten and graphs that deceive. We're just going to do the enlighten part today, and we'll save the deceptive graphs tomorrow. But you can tell where the division is. The deceptive graphs start like in this one. So we'll do a whole front and back of a page of notes. And then the homework is like 3 pages. It's a front and a back and then another page here. So after today, you should be able to do everything except 17 and 18. And we'll talk about that tomorrow. But yeah, so 1 through 6, I guess, for homework. And a lot of them, I think all of them, are creating graphs. So they may take a little bit of time. So don't wait and put it off, and maybe start it right away after we're done with these notes. So graphs that enlighten. On the first page, there are 5 of them. The first one is a dot plot. Okay. And here's what a dot plot looks like. Okay. Dot plot, they have pulse rates of males, and they have anywhere from the 40s all the way up to just under 110. And then they have dots that go up. So there's 2 people that were exactly 50. Okay. There's 1, 2, 3, 4, 5, 6, 7 that were exactly 60. On here, because there's only 4 in between, that means that they went by 2s. So this is 52, this is 54, 56, 58, 60, right? So they do not have values for 51 or 53 or any of the odd ending digits, okay? But one nice thing about doing a dot plot is that you can see the shape, kind of like a histogram. You can see kind of like with bars, you can see the shape of the data, okay? And this one has really nice element to it that all values can be read on the graph. Okay, on that histogram that we just got done doing, they would do bars, and they would have frequency here. We are not able to generate the original data values, but on a dot plot, you are able to. So I could look at that graph and say there are 7 of them that are exactly 60, right? I know exactly what those values are. So all values can be read using that graph, okay? And they're not lumped into a category of a bar like this one is, okay? So that is a dot plot. Dot plot. Notice that there is a heading, or I don't know if it's a heading, if it's below it, but a chart title, I guess. So make sure that when you do that on your homework assignment that you have that chart title. Number 2 is a stem and leaf plot. They call it a stem plot. I'm going to go stem/leaf plot. Features of a, let's go back to features of a dot plot. Displays the shape. We said that. It is usually possible to recreate the original list of data values. We said that, okay? Stem and leaf plot shows the shape of the distribution. I'll get to that. And then it retains the original data values. You can go back to the original data values. And then the sample data are sorted. I guess these ones are also sorted on a dot plot, so I don't know why that wasn't set over there. But anyway, so arranged in order. Here are male pulse rates, so the same data again, but here's your stem and leaf plots. So I don't know if you guys did these in elementary school, but here are your tens units, right? And then here are your ones units. So these 2 data points right here are 40 and 42. Right? Then these guys right here, if I look at this row, these are your stems, and these are your leaves, by the way. So in that one, I have 2 zeros, and that would be 50 and another 50, right? And then I have 1, 2, 3, 4, 5 2s, so that means 5 52s, okay? And so that's kind of how that guy works, all right? Stem and leaf plot. I wish I was there in person so I could ask you, have you done that before? And then maybe I wouldn't have to spend so much time on it, but that's okay. Down here, they have 10 and 2. That's 102. If you by chance have a category that doesn't have any data values, so let's say I have some in the 40s, 40 and 2, whatever, right? Okay, so that would be 2 40s and a 42, but I don't have any 50s. You still put a 5 there, and then you'll just start with the 60s and move on, right? You don't put anything in this spot, okay? And that just notes that there is nothing in the 50s range, right? But you don't skip over it. You don't go straight from 4 to 6. You do actually put a 5 in there, okay? So that is a stem and leaf plot. They did not put a chart title on it, but make sure that you put a chart title at the top so that we know what we're talking about, like male pulse rates, right? Okay, the third one, time series, okay? Time series graph reveals information about trends over time. This is like the only graph that we have where the bottom of the graph is some unit of time, like some time interval. Usually years, maybe it would be months, right? Maybe we're tracking temperature over the months of a year, right? Okay, so in this case, we're doing law enforcement fatalities, okay? And notice what happened here. Hey, it's the anniversary. It's the anniversary today, right? It's September 11th. So this, because there was such a huge skyrocket, that was the year 2001 when 9/11 happened, and that's the reason for that. But I can tell that because this chart enlightens and tells a story, right? Most charts tell a story, or most graphs tell a story, okay? So make sure that you are, labeling your axes and all that stuff, but this is one where your time intervals are on the bottom, okay? Whatever units you're doing of time. And they're just showing that trend over time. And notice that those are dots that are connected. Each one of those are individual data points, and they connect them using a line, okay? Not too bad. That was the third type of graph on this page. There are 5 on this page and then some more on the next page. And this one, that's number 4, sorry. Number 4 is a Pareto chart, not a burrito chart, but it's kind of pronounced the same way. Pareto chart. And basically this is a glorified bar chart, bar graph, okay? But it is a special bar graph in that it goes from highest frequency to lowest. Okay, so when I have my categories down here, a Pareto chart is all categorical data. So notice that like on here, these were all quantitative. Those are all numbers, years, things like that. Like pulse rates up here, those are all dealing with numbers. These are all categories, and they are stolen boats. So jet skis get stolen the most often. A motorboat gets stolen second most often, and sailboats get stolen probably because they're not very fast, right? Gets stolen the least often. And this is like your frequency over here. But they start and they go with the highest one first, and it just goes downhill from there. So this is a very like aesthetically pleasing graph because it has that trend that goes down, okay? So it shows the relative distribution of categorical data so that it's easier to compare the different categories. And then it draws attention to the most important or the more important categories because it goes high to low, okay? So glorified bar chart, notice that the bars don't touch. Bars don't touch like they do in a histogram, right? Why don't they touch? Because jet skis and motorboats are not like classes that are like right next to each other, right? We have to have a gap in between them because those intervals, it's not like a 60 to 70 and 70 to 80. It's not like classes that like are right next to each other, okay? Your bars don't touch in this case, all right? That was a Pareto chart. And then they have normal bar graphs like number 5 and a feature of a bar graph. So like bar graphs that are, I don't know, maybe we don't want to do a Pareto chart because we want to do like months of the year. So January we had this many sales, and February we have this many sales, and March we have this many sales, right? I wouldn't put those probably in order, like highest to lowest, like I would in a Pareto chart, just because it makes more sense to see them sequentially, like January, February, March. So that would just be a regular bar graph, and the frequency would be over here, okay? So it shows the relative distribution of categorical data so that it's easier to compare these different categories, okay? So something like that, all right? That's another example of a bar graph that is not a Pareto chart, okay? All right. Excuse me. Then we've got 2 more on this side. This is another example of that. So there's couple of examples that go with frequency polygon, and this is probably the most the one that people screw up the most. So this is chart number 6. This is a frequency polygon. Okay, it kind of like makes it sound a little bit more beefy than it actually is, a frequency polygon, but here is what it is, okay? In the last section, we did histograms, right? Okay, so these are McDonald's lunch service times. And in a histogram, we did your classes. So we might start at 50, and then 60 is the next class, and then 70 is the next class, and then 80 is the next class, right? And we would have bars that go like this. I don't know, whatever, right? Okay, in a frequency polygon, okay? It's very similar except for this. They instead find the midpoint, okay, which the midpoint of this class, since this class ends at 59, this class would be 55.5, right? Or 54.5. I did not do that right. That would be the middle of the class. Okay, let me say that again. This class, since it starts at 50 and the next class starts at 60, the class would end at 59, right? So the midpoint would be 54.5. What I'm going to do is rather than do a bar, I'm going to go to the midpoint and I'm going to put a dot, right? Then I'm going to go to the next midpoint, which would be 64.5, because again, it goes from 60 to 69, right? And we're going to go and put a dot there. And then we're going to go 74.5. Okay, so instead of making bars, I'm doing the midpoint, and I am going to do the dots, and then I connect those dots, and that makes a frequency polygon, right? So if I were to, this one had none right here. If I were to make, and I better make my bars touch. If I make this into a histogram, this is what it would look like, right? You're just using the midpoint, and you are doing that instead. Oh, my bars are not very big. Anyway, so something like that, right? Instead of doing a histogram, you're doing the midpoint and you're doing a dot and connecting the dots. And that is a frequency polygon, okay? So still have frequency on the side like a histogram does, but you're using midpoints. So maybe put a little midpoints there, okay? So that you know how to correctly label those. Again, make sure your chart titles are there. I take off points if you don't put those chart titles on there, by the way. So maybe make a note of that on your homework assignment, like put your chart titles in or you'll miss points. Okay, this is a relative frequency polygon. Relative meaning percents. So instead of doing regular frequency here, we've talked about that before, they put percents down, but it doesn't change the shape of the graph. Notice that like McDonald's, this pink one, whatever, is the same as the pink one here, right? But what they did is they also, not only did they make it a relative frequency, but they also made it stacked where we're comparing Dunkin' Donuts to McDonald's, okay? And we did that a while back. But again, these are the midpoints, right, of the classes, okay? And so instead of doing the bars, right, they have the midpoints of the classes. And they have this really nice, like we would not be able to compare Dunkin' Donuts and McDonald's if this was a histogram, true? Like my bars would end up being like on top of each other and it would be a dang mess. So sometimes they will, like, I don't know if you've seen this before, where they'll do like a bar here and then the other one's bar here. And then they'll do, so like the green ones represent McDonald's and the orange ones represent, Dunkin' Donuts. But the problem with that is that these classes, these green ones, don't touch, right? And the classes should touch at the bottom. So it's better to do a frequency polygon here where I can just, put that data in there and then you can see the lines on top of each other and compare to Dunkin' Donuts and McDonald's. So lunch drive-through service times, we can note that like Dunkin' Donuts, their peak is a lot less than what McDonald's is, which means that their service times are slightly faster, okay? So there's that. Not only did they do relative, which is percent, but they did two of them on one so that we can compare, which is a lot better method than trying to do a double bar graph. That's kind of messy, okay? In fact, we don't even have a double bar graph as an option on here, okay? And the last one is a pie chart, okay? Pie chart shows the distribution of categorical data. So again, these are our categories. And I don't like the way that they did their pie chart, okay? So I'm going to fix it over here and I'm going to show you how I like it done, okay? A lot of you just got done taking trig, some of you maybe, I don't know, last year. But when we graph in a circle, we start in the center and we go out to the right side, and this is like standard position for a graph, right? Like we start, this is how quadrant 1 and quadrant 2, quadrant 3, quadrant 4 start, and then we rotate up that direction. So here's what I want you to do. I want you to start in that category, and then you start with the largest chunk, which is jet ski, which is a little less than half, like half of the circle would be that much. So a little less than half would end up being like over there, and this is going to be the jet ski section, okay? Then you go with the second highest category. So I'm going to go with this pink one right here, the red one, and I start where this guy stops, and that one is like I don't know, a little bit more than a fourth of the way, right? So that one's going to be the motorboat. And then we have the green one, which is a utility or fishing boat, and that's going to be about that much. And then we've got the purpley one, which is about the same, maybe a little less than the motorboat one, so like there. And then we've got our smallest category, and I didn't do that very good, okay? So utility boat, inboard, and sailboat, that's how all of those go. But you want to start him in this corner. Now, when you are creating your pie chart, what you want to do is you want to figure out, actually, do I make you do that in the homework assignment? Pie chart. Yeah. Use the information from exercise 4. Yeah. Okay, so I'll help you do number 5. Let's just get you started on number 5 on the homework assignment, all right? So we have journal retractions. In a study of retractions mean they like took it out of publication, right? So this journal article, whatever, was published, and then they like for some reason were like, oh nope, there's false information in there, so they yanked it off the shelf, right? In a biomedical journal, so something was wrong with their research or whatever, so they pulled it off the shelf, right? They like made it not be in publication anymore, so they retracted their statement, right? So we had 436 were due to an error, 201 were due to plagiarism, 888 were due to fraud, and 291 were due to duplications of the publication. And 287 had other causes. So we had like a lot of things going on here. So I'm going to write this down. 436 equals error. 201 equals plagiarism. 888 equals fraud. 291 is equal to duplications. And 287 equals other. Okay, so what they're going to have you do here is they're going to have you, let's see, what are we making? Construct a Pareto chart. So in that case, you're going to put the highest category first, which is going to be fraud. So I'll help you get that started. Fraud. And then you're going to put your number over here, like your frequency. I don't remember what they called it for a Pareto chart. Do they call it frequency? Okay, they just put stolen boats, so whatever. You can say number of articles if you want to, or frequency. I'm just going to do frequency. So fraud, and then you would go up and you would do your bars, right? And then you'd go the next one down and the next one down, right? I have no idea, okay? So do those. Now, when you're doing a pie chart, you're going to add those up, and you're going to figure out what percentages you have. And I'm very picky about my pie charts, so make me happy, please. I'm going to add these up for you. 436 plus 201 plus, I'm using a phone calculator, so please, like, be nice to me, plus 287. And that is 2103. Okay, so I'm going to go ahead and do these percentages. So if I do find error, I'm taking 436 and dividing by the 2103. 436 divided by 2103. And that is about 20.7%. If you want to do that, 201 divided by 2103 is a little less than 10%, so 9.6%. 888 divided by 2103 is 42.2%. I'm running into my other stuff. 291 divided by 2103 is 13 point. Make sure you're writing this down, by the way. You need this information. I don't. 287 divided by 2103, and that is 13 point. This other category is 13.6%. Okay, so all those should add up to be 100%, but that is the percentages of them. I'm going to start with the biggest one, which is fraud, and we're going to start him in this corner, right? And we're doing 42%. 50% would be here, right? 25% would be there. All right, that's 50, 25%. Halfway between would be 37.5%, right? That's 37.5%. So 42 might be like, I don't know, let's go. Yeah, let's go there. Let's go there. Let's go there. Right there. Okay? We're going to say that's 42%. Let me get everything else erased. There we go. Oh, maybe. Come on. Erased my line. Something like that. okay? And that is going to be fraud, and I'm going to put fraud, and I'm going to put 42.2%, okay? Then from there, I'm going to go 20% is the next one, okay? All right, if he is a 90-degree angle, that is 25%, right? So if I'm making him a 90-degree angle, so I want to go a little less than that, right? I'm going to go 20%, so he's going to be like a little bit over there-ish, right? If we were going to do this correctly, by the way, like 100% correctly, what I would do is I would get out a protractor, and I would figure out 20.7%, and I would take that times 360 degrees, and then it would end up being like, I don't know, 72 degrees or something like that, close to that, right? Because 2 times 36 is 72. Anyway, 72 degrees, and then I would like use a protractor and find 72 degrees on my protractor, and I would do that, right? Okay, I'm not going to make you do that today, but maybe we will eventually, all right? Then the next categories are 13.8 and 13.6. I got to do the 13.8 first. So again, this is 25 degrees, okay? And 13 plus 13 is 26, right? So it's going to be about half of that. And this one's going to be like slightly larger than that, right? Okay? And then I'm going to erase if I can. Boop. Nope. I'm going to go slightly larger. Something like that, right? So 13.8 goes here, percent. That is duplication. Oop, duplication. 13.6 is other. This is my other category. And this is 13.6%. And then the last one is plagiarism. Plagiarism. I don't know if I spelled that right, but that is 9.6%. Ooh, that slice of pie. Yeah, he looks all right. He's okay. Chart title. Reasons for retractions in reasons for retractions in biomedical journals. There you go. Okay, make sure you're putting your access titles on there. Make sure you're putting your chart labels and all the things on there, okay? And each one of those that you do, but there's number 5 already kind of done for you, okay? Hopefully yours looks a little bit less messy than mine, but there's that, okay? All right, there you go. Do the best you can. Try to get through 1 through 6, and then we will go over questions tomorrow, and we will do the deceptive graphs tomorrow, okay? All right, there you go. Use your time.